My name is Jinnai, and I'm going to talk about model-based minimum base risk decoding for text generation. So text generation problem is involved in many NLP tasks. For example, image captioning, you have an image and you have a model, P model, which is to output some kind of sequence or text H given a context H. And this context can be anything, like for example in translation you're given this is black cat in Chinese, and then the model gonna translate it into English, a black cat. So we're interested in using this P model to generate interesting or useful text. So that's the problem, text generation problem. So the currently most usually algorithm for text generation is beam search decoding. So beam search selects the text that maximize the model probability. So it's a map estimate, maximum a posteriori estimate, in a sense that you just simply maximize the P model. So it sounds very intuitive that because P model gonna, train to generate useful text. So it is very intuitive. However, several existing literature talk about its shortcoming. Sequences with the highest model probability is often a bad sequence. For example, it can even be an empty sequence. This is a very interesting phenomena. Actually, like beam search is working, but if you try to optimize too much on this P model, it fails. So yeah, that's why we want to have other kinds of objective function we can maximize. And that's where MBR sits, minimum base risk decoding. The goal is to maximize the quality of the text. How do we do this? Let's assume you have an image and a prompt saying what's in picture. Then you query the model to generate multiple outputs. Black cat, a cat, or black kitten, anything can be possible for being the output. And what MBR does is it computes the similarity between each pair of samples using a utility function U. So yeah, so we have utility function U, which is basically some kind of function which computes the similarity or distance. And MBR gonna select a sequence or sample which is which has the highest similarity between all the other sequences. So simply you get what's in the middle of the sample space. So yeah, the procedure can be understood as selecting the center point. However, the problem is that precisely estimating where the center is gonna require a lot of samples. So MBR needs a lot of samples, and thus it is very slow compared to beam search. What we propose in our paper is to solve this problem. That is, we give a weight to these samples according to its generation probability P. So, for example, a cat, there's a high probability of generating this sentence, so we give more weights. And for a sequence which has low generation probability, we will weight it less. So that's how our method works. Well, that sounds a good idea, but wouldn't it increase the estimation error? That's an interesting question, but no. Actually, we find that we can weight to these samples without increasing the estimation error in terms of expectation. How it does is that we remove duplicated samples and weight samples using the P model. So We call this method model-based minimum-based risk decoding. Um, Formally, what it does is that prior work estimate a set of samples using a Monte Carlo estimate, whereas in our work we don't do Monte Carlo estimate in a sense that we replace the p hat, which is a Monte Carlo estimate of p model, with p model itself. So the observation here is that Monte Carlo estimate is done in statistics oftenly because we don't have an access to the p model. However, in text generation scenario, we have a full access of p model unless it's API based closed source model. So yeah, we have p model, so why don't we use it? Because it's better than Monte Carlo estimate because it's the true value. Okay, so actually how it works is described in the paper. So this is an example of how the Monte Carlo estimate and our model-based estimate gonna work. Is that, so let's say we have two techists, two occurrence of this text, and two for this one, and one for this one, and there's no other techists. And say our target probability distribution is like this. Monte Carlo estimate, what it does is that we simply multiply and normalize by these occurrences. So it can be 0.4, 0.4, 0.2, respectively. On the other side, model-based estimate, we ignore the occurrences and we just simply use this target P normalized to sum to 1. So what it gets is the 0.6, 0.2, 0.2, because we simply multiply by 2 and it's gonna add up to 1. So this is the model difference between Monte Carlo estimate, which use occurrences of the samples, whereas model-based estimate use the P itself. And with respect to KL divergence, it is much smaller than Monte Carlo estimate. And it's not just for this example. We can actually prove that for any kinds of sample text, model-based estimates is guaranteed to be closer to the model, to the true model probability than Monte Carlo estimate, measured by KL divergence. So yeah, so that means model-based estimate is a better estimator. Well, we were talking about MBR decoding. Do we actually care if, or if not, the KL gonna be larger? Actually, we find that the scale divergence really matters for MBR decoding. Divergence from the model probability correlates with the text quality. That is, if you can estimate P model better, then you get a higher quality text. So on the right, we have KL divergence on the x-axis, and y is the quality of the text. And you can see that it is strongly correlated, and it correlates for any algorithm we have tried. So we implemented MBMBR and evaluated for a machine translation, text summarization, and image captionings, and we find that our method outperforms the baseline MBR. Okay, so the summary is that MBMBR uses the model probability instead of Monte Carlo estimate, so that it is much easier to estimate, and the model probability easier. We also conducted experiments that shows MBR is effective in the domains we have tested. Good news is that it is available at MBR's library, which you can import by pip install MBRs. So that's it. Our idea is simple and it's already implemented in library. So you wanna try it. Thank you very much.